So today's topic is Dalton's law. It is similar to Henry law, and it is defined as the mole fraction as solubility. Here we take mole fraction as its solubility, and it is defined as the mole fraction of gas in solution is proportional to the partial pressure of gas over the solution. So it is like if we have a solute component in liquid phase, then it produces vapor. So the amount of gas, mole fraction of solute, is directly proportional. The amount of gas that is present inside the liquid is directly proportional to the partial pressure which is present over the liquid interface and which is produced by the liquid in which we have added the solute. So the mole fraction of solute in solution is directly proportional to the partial pressure of that gas. So from these definition we also understand that it is for gas in liquid. So here we are taking solute which is gas component. So we write this statement as mole fraction directly proportional to the partial pressure. So by solving this further, we get a proportionality constant, and I'm taking it as k dash. So by changing by cross multiplication, we will get P equal to X, that is mole fraction, upon k dash. Now we are taking 1 upon k dash as a new proportionality constant, and we call it as kh. So this is the new formula, new expression to show Dalton's law, which is defined as the partial pressure of gas. We can see from the formula the partial pressure of the gas is related to mole fraction. So by interchanging the side, as in first equation we can see that the mole fraction is directly proportional to the partial pressure, Now we have changed our expression as the partial pressure of the vapor phase is directly proportional to the mole fraction of gas in solution. So it is very easy. So we have this expression and we uses this expression for every numerical question, but we can define this law by two statements. First is by saying that the mole fraction of gas is directly proportional to the partial pressure, or we can also change this by saying the partial pressure of vapor phase is directly proportional to mole fraction. So here as I've written kh, this is known as Henry's constant. And if I draw the graph of this equation, it can easily be drawn by taking mole fraction on x-axis and partial pressure on y-axis. So we will get a straight line graph and its slope will be kh. If I talk about the unit of kh, then it can easily be calculated by the formula as kh is equal to p upon x. So we will get pressure is usually taken in terms of atm, and mole fraction has no unit, so kh unit will be equal to unit of partial pressure. So it can be atm, it can be bar, and it depends on the unit of partial pressure. So this is our topic in which what we have studied, that Dalton's law, it is similar to Henry's law, but here in Dalton's law we take the concept of solubility by taking mole fraction. We talk about solubility in terms of mole fraction, and second important thing is that it is for gas and liquid. For those solution like gas in liquid, any gas which is dissolved in liquid, so its statement is as the mole fraction of gas in solution is proportional to partial pressure, which is changed to this statement which I have highlighted by yellow color. So P is equal to kh into x. So if I write it more clearly, so we can say that mole fraction of partial pressure of solute, which is a gas, is equal to kh into mole fraction of solute. So it is very easy to understand. So it is for gas and liquid, and here we are taking mole fraction of solute, and the pressure is just because of the solute which is gas. So thank you so much.